Es ist 10 Uhr. Herzlichen guten Morgen von meiner Seite. Ich bin heute die Referentin aus dem Hause Boston und begrüße Sie sehr herzlich zum Webinar. Mein Name ist Christina Seel. Ich bin hier im Marketing angestellt bei der Boston schon seit 4 Jahren und freue mich, dieses Webinar heute mit Ihnen gemeinsam gestalten zu können. Unser heutiger Titel ist Artificial Intelligence and the Future of Datacenter-Technology. Dieses Webinar wird zusammen mit der Micron durchgeführt. Kurz zu unserem Housekeeping. Das Webinar, was Sie heute vor sich finden, bekommen Sie aufgezeichnet, zugeschickt, samt Präsentation in PDF. Wenn Sie Fragen haben, jederzeit sehr, sehr gerne Fragen. Bitte alle Fragen in den Chat stellen, damit wir sie am Ende auch beantworten können und hier auch sammeln, damit einfach während der Präsentation durchgängig präsentiert werden kann und keine Inhalte verloren gehen. Genau, das Webinar wird auf Englisch gehalten. Von daher starte ich einfach mal mit der Vorstellung, wenn es funktioniert, mit einem Klick. Yes. Okay, then let's start. Switch into English. My person or referent for this webinar will be Esther Spanjer. She is a director in enterprise channel business development at Micron, and I'm in the moderation, Christina Seer, head of marketing at Boston Dach. So I would like to hand over to Esther. Welcome, Esther. Thank you for this webinar.
Thank you, Christina. It's a pleasure to be here. I always love collaborating with Boston. It's always great conversations and great technical topics. So thank you for inviting me.
Great, thank you. So I would like to change to your screen, right?
Yep. Okay. Can you see my screen?
Yes, yes. It's to see. Thank you.
Okay, fantastic. Thank you, Christina. And thank you for those that have joined the webinar this morning. It's a pleasure, of course, to be here with you. Like Christina mentioned, if there's any questions, feel free to put them in the chat. We have time at the end of the presentation to go over any questions you have. I will also have my contact information, at the end of the presentation. So my name, just as a reminder, my name is Esther Spanjer. I am responsible for business development for Micron, specifically for the enterprise products in the channel. So I focus primarily on everything, both memory and storage, that goes into a server and that is going to eventually put into a data center. So that is my focus. And today we will be talking about those servers that are going to be running all of your AI workloads and applications, and what are the technical requirements for those when it comes to memory and storage. So a few words about Micron, just to give you a flavor of who we are. I promise you I won't spend a lot of time on the typical corporate slides, but really just 2 minutes on who we are. So Micron is a large semiconductor manufacturer, of this 4th largest semiconductor company in the world. We've been around for a long time, 45 years. Our headquarters is in the United States, and we are pretty much a worldwide company. We have a footprint in 17 different countries around the world. We have 11 manufacturing sites and labs around the world, and we are almost 45,000 people that work for the company. So large company. We are the 3rd largest DRAM company, and we are the 3rd largest NAND-based company. So we are, one of the few semiconductor companies in the world that do both NAND and DRAM. Now, the NAND and DRAM, the core of everything that we do, basically comes down to the actual technology. We develop and make wafers. Those wafers turn into chips, and those chips turn into a product for a variety of sub-markets, automotive, industrial, mobile, data center, laptops, embedded, you name it. Today, of course, we're specifically going to talk about those products that we manufacture that go into a data center, but the core of all of our products is the actual underlying technology of both DRAM and NAND. Now we also, and this is something that I think we're not very known about, but very, very focused on innovation and technology. We currently have on our name 57,000 patents. And if you look at this picture that is kind of showing here, you see kind of a hallway with panels, blue panels, all these little blurbs that you see on these panels is basically the name of a patent, the number of a patent, and the patent holder. And this is actually an actual hall in our headquarters in Boise. So lots of focus on innovation and coming up with the latest and greatest technology. And of course, today, we're going to talk about the innovation that we are focusing on around AI. There's a lot of things, a lot of new technologies that are being developed and that are, being brought to market as a result of the workloads of AI. And, AI really is everywhere. We're seeing it in, I think the first markets that will really pick up AI are going to be, in manufacturing, healthcare, and business. And, the variety of the demands of all these applications is quite wide, but the actual demand on the hardware that needs to service all of these different applications and different market segments is, quite similar. And so that is really the topic for today, is what are all the differences in the hardware and where are the optimizations that can be found. So when we're looking at the growth of AI in the market, it is actually quite staggering. So when you compare the amount of AI servers that shipped last year versus this year, it's a growth. According to one of the analysts, this particular analyst is called TrendForce. They claim that the amount of AI servers this year grew 41.5%. To get a total market share of 12.2% of the overall server shipments this year. So, and that trend we're expecting to see will grow, over the next few years. Now, the big difference between a regular server and an AI server, from a memory and storage perspective, is that AI servers demand a lot more memory and storage than a typical standard, data center server. And so what exactly are the requirements and the differences in all the different tiers is what I will be talking about during today's presentation. So when we're looking at any data center at the moment that needs to service AI, I think it is very clear that the challenges that the designers are facing is really to try to find the optimal balance between, the best performance, because, we're needing, AI is very, very performance hungry, to also have, the right capacity, whether it is in memory or in a storage and SSD device. The AI is very capacity hungry as well, but all of that needs to be done in a very limited power envelope, as data centers are basically having to deal with a certain finite amount of power they're able to get from the grid. So we have to do more with less. And so finding optimizations and finding the right technologies to do that is, of course, the key to the proper AI implementation. So what we're seeing in the data center is kind of like 3 different classes of hardware that we will find. And so this is kind of a very generic representation, but we will obviously go into the details of all of these different kind of configurations. So when you're looking at AI, there needs to be a differentiation between the AI workloads that you're running, whether that's a training workload. Are you training your your AI engine, and you need to have a large data set that you need to move through that AI engine so that you can train your model, or and that would be in this kind of big fat server on the left that would require lots and lots of GPU. It would require very high performance SSDs and also a lot of DRAM. So this is where typical the amount of SSDs versus GPUs can even reach a 1-to-1 ratio. You can have DDR5 as well as CXL memory, and it's really all about trying to train and crunch as much data in a short amount of time as fast as possible. The second server that you're seeing here that stays optimized for inference, this is really the kind of server that you would deploy once your model was created, and now you actually need to start utilizing that model and implementing it when you have new data coming in that actually needs to be analyzed, and a prediction needs to be given based upon that data. The prediction is, of course, based upon the training that you have done. So the server that you use in this case, the server that's optimized for inference, typically has less GPU, has more moderate DRAM requirements, and or also more moderate SSD requirements. So the typical ratio between SSD and GPU here would be 1-to-6, and the requirements overall are less performance intense and more are trying to find the right balance between performance, capacity, and cost. And then at the bottom, this would be kind of like an external storage pool for large data lakes, where you basically would be storing all of the data that you would feed into the model, into the AI model that you require for the training. And also there, we're seeing more and more transitions from hard disk drives moving to SSDs, again, for performance reasons. And I will share a bit later in the presentation the actual reason for that. So this is what we're going to talk about, the different tiers and the different requirements of memory and storage in these different classes of servers, and what their benefits are, and of course what the options are in the market today. So starting off, when we're looking at kind of all of the different memory and storage that is required in the data center, we kind of can stage it into different tiers, going from memory that sits very, very close to the GPU, all the way down to storage that will store the data in data lakes. So near memory, as we call it, is really meant for memory that sits very, very close to the GPU, needs to have very high bandwidth to enable, for example, large language model trainings and inference. When you're looking at main memory, this would be your typical DRAM, DDR5 memory that is what your standard memory pool is, that you are already quite familiar with, in a standard server today. Expansion memory, this would be kind of a new tier of memory where we find ways to increase the amount of accessible memory the capacity through the PCI bus. So here we connect memory to the PCI Express bus and find ways to expand our overall address range for the accessible memory. Then, of course, we have local SSDs for data caching purposes, and in the end, we have SSDs that are, going to support our data lakes in the external storage arrays. So the different tiers are basically filled with different classes of products. And so when we're looking at the different classes of product, I'm basically going to walk you through all these different classes and what the status of the market is today, what is going to be released, what was already released, and what are the benefits of each of these different classes. So we're going to start off with near memory, HBM3. So HBM3 is a technology that was released recently by Micron in collaboration with NVIDIA. In essence, it's a chip that includes both a GPU and memory on the same chip. It's a GPU from NVIDIA. It's memory from Micron. The technology is kind of fused together to create a chip that is soldered directly onto the motherboard and will be sitting, it's basically sitting together with a GPU. So the intent really is here to have the memory sit as close as possible to the GPU, and you can have multiple chips within your motherboard. Now, this is not something that would be sold through the channel. This is something that motherboard vendors and server vendors already will incorporate onto their motherboards and the server that you will look at. But I just wanted to kind of share with you that this is a new tier of technology, a new tier of memory that recently was enabled into the market. We've seen HBM1, HBM2, HBM2E, HBM3, and now 3E. So it's just the latest generation providing high capacity, very, very high bandwidth, and lower power consumption compared to previous HBM generations. And so again, with the goal in mind of optimizing power in a data center, this is a great step forward, whereby we're getting more performance, more capacity for less power. Moving on to kind of like the next tier, this is your main memory, your typical DRAM module. We are today, in the generation of DDR5 modules with 5600 speed, so 5600 mega transfers per second. We are able to go with the DDR5 interface all the way up to 8,000 mega transfers per second, sometime in the next year or two. But today, 5600 is is kind of the speed that we are shipping today. The next speed up will be 6600, and that will be coming out at the end of the year. Also, the maximum capacity that Micron supports is 128 gigabyte. The difference between the 128 gigabyte of Micron versus some of our competition is that we are able to build this 128 gigabyte using something that we call single die packaging, meaning we don't have to stack multiple layers of silicon on top of each other to get to the capacity that we need. We actually have, we can do it in what we call single die packaging. And the advantage of doing that is that it is, uses less power, it is lower latency, and it is also more cost effective when you're doing something called 3D stacking in a DIMM module that is quite an expensive way of manufacturing a high capacity product. So single die packaging always will be a better option, both from a cost perspective as well as from a latency and power consumption perspective. A new technology that is about to be released into the market, Micron recently announced it, is something that we call MRDIMM. And MRDIMM stands for multiplexed RDIMM. This is a new technology that allows us to go to much higher bandwidth. So we can go up to theoretically 12,800 megatransfers per second. The first generation that is going to be released by the end of the year will be 8,800 megatransfers per second. So it is a big step up in bandwidth, and we can also go up to higher capacities. You see on this image here that we kind of have like a large form factor here. Instead of your standard DIMM form factor, we can now go up to twice as high, and that would allow us to get to double the capacity. So MRDIMM is a new technology. So just to give you an idea of kind of the difference between an MRDIMM and a regular DIMM, in essence, it's basically it's kind of two DIMMs built into one. We have two DDR ranks that are basically being multiplexed between the two of them. And when you start multiplexing multiple ranks of memory, you basically can increase the performance tremendously. So while the mechanical and electrical interface of an MRDIMM is exactly the same as a regular RDIMM, we now have the ability to go to higher speeds and to go to a higher capacity. So it is, if you will, two DIMMs built into one to enable us to do that. There will be different capacity configurations and kind of ranking configurations, but the maximum capacity that you will be able to get an MRDIMM within the next, call it year or so, will be up to 256 gigabyte. Now, this is, definitely at the moment still a relatively new tier of products, and we expect that the first customers to pick up this kind of product will be those customers that are very, very intense, require intense, AI workloads with lots and lots of performance requirements. HPC is where we see, demand. Basically, any application that is very, very performance and or capacity hungry. So to give you an idea, for HPC workloads, we see that, they require, the highest performance. It's all about bandwidth. And so MRDIMMs really provide, 20 to 30%, bandwidth improvement for workloads such as OpenFOAM or Pod3D, which are your very typical HPC workloads. We see also improved what we call performance per watt. So that is also important again for those data centers that are working on optimizing the energy consumption. It really is about, it's not only about the performance, but it's also how much power do you need to get to that performance. For AI, we see 15 to 20% performance improvement on token returns for large language models with 50% lower latency, virtual multi-tenant. We don't yet have real measured workload data there, but we do believe that this would be a very good target application for the MRDIMM. And then financial services, that really speaks for itself. It's all about bandwidth and low latency there when you're looking at high frequency trading. So those are all some kind of target applications that we believe will be a good fit for MRDIMMs. Now, some measurements that we did here, where we took a 256 gigabyte DIMM product based upon 6400 speed, compared it to an MRDIMM with 8800 speed. And it's clear that we're going to get more and more bandwidth when we're going to these higher performances again, which is what we want to see when we're going to run more and more AI intensive workloads. Another example is the machine learning algorithms. When they're scaling to larger and larger data set sizes, we need to get to higher and higher capacities. So it's not only increased bandwidth, but it's also increased capacity. And so, a 256 gigabyte, what we call TFF, tall form factor, MRDIMM, basically requires, provides a better enablement for these machine learning algorithms in the data center. All right, so the configurations that Micron will come out with in January, February of next year, samples will be in calendar Q4. We're going to have 32 gigabyte all the way up to 128 gigabyte with the first speed range of 8800 mega transfers per second. So those will be the first configurations that we will come out with that will be brought to the market. We are already having conversations with customers about this that want to start doing testing, and so it definitely is real. We're seeing a lot of interest from both as I said, the HPC world and the AI world. So then let's go on to the next year. So we talked about near memory, we talked about main memory. Now the next tier is kind of like what we call expansion memory. So when these large language models in AI continue to grow, we need to have the ability to add more memory capacity quick and easy. So this is where CXL is coming into play. CXL basically is memory that is kind of built into a PCIe device. You connect that memory to the PCIe Express bus. We then call it CXL. But CXL in essence is memory that is connected to the PCI Express bus. So it is not the same performance as when you connect memory directly to the DRAM bus, to the DDR5 bus, but it does allow you to increase your capacity, your accessible memory capacity by quite a lot. We can get up to 256 gigabyte of memory in one of these devices. So it really is a way of expanding the maximum capable memory that you can have. And then, instead of, kind of putting more and more regular DDR5 memory in there, and at some point you're going to run out of slots, then there is a way of starting to tier the memory by expanding it on the CXL on the PCI Express bus. At the moment, this is a product that is released, but it is only supported by Micron through the OEM partners, not yet in the channel. Once we see, of course, enough demand in the channel, we will start supporting that as well in the channel. And then, sorry, I'm jumping this one. And then we are coming to our typical SSD that we've been using already a lot, as a cache, as a local SSD. We have multiple products here that can be used in your server, PCIe Gen 4, PCIe Gen 5, and each of them obviously have their own pros and cons. So gonna talk about the first one. So these large servers that have lots and lots of GPUs in them that are being used for training purposes, they will require the highest performance of SSD in them, so that they can feed the data as fast as possible into the GPUs. And so getting the highest performance SSD in there is very, very important. So from a Micron perspective, we have a product called the 9400 that is a product that goes up to 30 terabytes. So you can have a large cache that goes up to 7 gigabytes per second read write, and very, very high random read and write performance. So again, this would be a product that you would be using in an AI server that is focused primarily on training, where you have a large ratio of GPUs sitting in that server. The next class of server that we will typically find in a data center would be your general purpose server or your inference server, where there's going to be less GPUs, it's going to be less compute intensive, and here the choice of SSD is going to be much more the result of finding the right balance between performance, cost, and capacity. So our mainstream NVMe would be a typical choice, whereby you have a product that goes up to 15 terabyte, is more moderate in performance than the previous SSD that we talked about, but obviously is more cost effective compared to that previous SSD. Now, we also are starting to transition to PCIe Gen 5. And of course, once we are going to adopt PCIe Gen 5 in our servers, we're starting to see a lot more performance that we are able to get out of our servers, because we are transitioning to a faster performance tier. PCIe Gen 5 provides double the performance than PCIe Gen 4. So Micron is releasing a new product, a new PCIe Gen 5 called the 9550. So this will be our follow-on to our 9400, and we basically this at the moment is designated as the fastest SSD in the market today. We are releasing this product in the channel in November, so not very far out. And when your data center infrastructure can really take advantage of PCIe Gen 5, then this would be a very good product to look at. Mind you that once you do start looking at PCIe Gen 5, the backend network speeds need to start also be upgraded, as otherwise you're going to have a very fast way of getting the data in and out of the SSD. But if you then do not have a fast way to get it in and out of the network or across the network, then you didn't gain very much. So PCIe Gen 5 really makes sense when there is also going to be an upgrade to the bandwidth of the network that is connecting all these servers together. To give you an idea of the claim that we are talking about, that when we say we are the world's fastest data center, this is just a comparison against some of the direct competition that we are facing in this market segment. And so, basically all the typical competition we're seeing here is Samsung and Kioxia, and we are currently measuring across quite a few of the performance attributes at a much better rate than our competition. So when you're starting to look at PCIe Gen 5, I obviously would highly recommend that you also take a serious look at the 9550. Now, one example where we're seeing kind of these high performance SSDs being deployed is in a in a configuration that we call NVIDIA GPU Direct Storage. And this is basically a configuration where the data goes directly from the SSD to the GPU without having to go through a PCIe switch. And so that makes, so this is of course something that you will need a GPU that enables this from, typically NVIDIA. But when you have the ability to get the data path directly from the SSD into the GPU and not having to go via the PCIe switch and go back and forth through the DRAM of the CPU, etc., you're able to get a much faster performance optimization because of this. And so we've done quite a lot of testing with GPU direct storage of the 9550 and our competition. And also here, we found that basically better throughput, lower power, and less energy used to transfer data. So when you're looking again at these kind of AI optimized hardware configurations, looking not only at the performance but also at the power is going to be very, very important in the decision-making process of what hardware, memory, and storage you're going to be using in your configuration. And so the last tier in this whole kind of AI data center optimization is going to be the SSDs that we find on the data lakes. And in this case, we're looking at a very, very high capacity SSD that is kind of replacing hard disk drives. Now, this has been the eternal discussion when I talk to my customers, when they say, okay, so when is SSD finally replacing hard disk drive? When is the price of an SSD finally going to be, at the level that we can replace it? And the answer is really, well, on $1 per gigabyte basis, SSDs and hard disk drives are never going to be at par. I truly believe that. But when we're looking at the overall system cost, there might be some advantages in certain configurations to replace hard disk drives with SSDs. And looking at a data lake that is going to be used for AI training purposes, I think is a very good example. So typically, when you need to train an AI model, you need to crunch a lot of data to actually feed that AI model, to actually start teaching the model of what it needs to be learning. Now, crunching that much data, that data needs to be stored onto something. In the past, we've stored that data on external hard disk drives because that was the lowest cost of storage that was available to us. Now, the challenge with hard disk drives is that, as we all know, they are slow. And so when we're start putting this into an AI training model, the challenge that we're seeing is that it takes a lot of time to get the data from the storage device, from the hard disk drive, into the GPU server that needs to crunch that data. And so then you get to a stage where the GPUs might be sitting idle and basically will be waiting for the data to arrive. Now, the GPUs in your system will be the most expensive part of your system. So the focus really should be on optimizing your GPU idle time. You don't want your GPUs to be sitting idle. And so when you're replacing your hard disk drives with SSDs, you can imagine that you now have a much faster way of feeding that data into your GPUs. The test that we specifically did took a 100 terabyte data lake, and we fed that into the GPU server, and it was 4 days faster when we used SSDs than with hard disk drives. So when you're running a data center that does a lot of AI training, you can imagine that 4-day optimization is tremendous, even though the SSDs are higher cost than the hard disk drives. Still, the optimization of how quickly you can get results really should be a benefit versus the individual cost of the SSD. So this is a TCO discussion more than an individual component discussion. And so when we're looking at, the overall, technology and products that we can find in the data center to enable this new AI infrastructure, you see that there is a lot of different types of products, both on the memory and the storage side, that each have a different contribution and a different optimization of, finding the right balance between power, performance, cost, and, capacity. And so the 8 product families that I show you on this slide are basically the 8 product families that we walk through in this presentation. The HBM3 and the CXL products are currently not available in the channel. They're only available through our OEM partners, but all the other products can be available through our channel partners. Of course, with Boston, we build together configurations. And I hope that you've learned a little bit more about the different optimizations and the different choices you have in building the right configuration in your data center. And with that, I would like to finish off this presentation. We have a whole website dedicated to AI, micron.com/AI. I also put here my email. Feel free to reach out to me directly. I'm happy to answer any questions. And with that, Christina, back to you for any questions from the audience.
Great. Thank you, Esther. It was a pleasure to go through the charts as well and look after all news you have provided this morning. Thanks so much. Hope you see the white screen. Yes, you do.
Yes, we are. Yeah.
Great, thank you. Ich switche auf Deutsch zurück. Also wenn Sie Fragen haben zum Thema AI, zur Serverarchitektur, schöpfen Sie das Potenzial bitte vollständig aus. Wenn Sie hier Bedarf haben, kommen Sie auf unser Boston-Team zu. Wir können hier eine individuelle Lösung für Sie erstellen. Fragen Sie einfach an, kommen Sie mit dem Bedarf auf uns zu. Wir finden auf jeden Fall die passende Lösung für Ihren Bedarf. Und falls Sie dazu noch Backup und Recovery-Lösung benötigen, wir finden auch hier für die passende Lösung oder auch eine USV für unterbrechungsfreie Stromversorgung. Kommen Sie bitte einfach auf uns zu. Wir würden uns sehr freuen. Ja, mit diesen Worten ein kurzer Überblick, was kommt demnächst. Wir sind demnächst auch auf vielen Veranstaltungen unterwegs, haben hier auch ein weiteres Webinar derzeit schon aufgesetzt, und zwar am 20. September. Hier sehen Sie auf der linken Seite wird es ein Update zu NVIDIA geben, zu NVIDIA Blackwell der neuen Generation, sowie den nächsten Generation von den DGX-Systemen. Hier gibt es auch schon eine Anmeldung oder Anmeldelink dazu. In Planung haben wir im Moment für den 18. Oktober Upon Scale. Hier wird mich mein Kollege Thorsten Schäfer unterstützen und dieses Webinar leiten. Und am 25. Oktober höchstwahrscheinlich Data Core. Es wird hier um NIS 2, um das neue Gesetz geben. Hier klären wir das Wie, wer, was, warum. Also wie betrifft uns das NIS 2 Gesetz in der Branche? Wie wirkt es sich aus? Wir lassen keine Fragen offen. Von daher sehr, sehr gerne anmelden, sobald der Link vorhanden ist. Auf der rechten Seite sehen Sie dann die Veranstaltung. Wir sind demnächst auf einigen Veranstaltungen mit unserem Boston-Team unterwegs, mit unseren internationalen. In der Dachregion findet die Biotech X statt. Hier haben wir einen Messestand in Basel. Am 9. und 10. Oktober findet die Biotech X statt, eine pharmazeutische Messe. kommen Sie gerne auf uns zu, wenn Sie teilnehmen oder in der Nähe von Basel sind. Es müssten derzeit noch viele oder einige Tickets vorhanden sein, so wie ich gesehen habe. Auch sind wir auf der Prospect X von Bike6 in Landshut, auch im Ausstellungsbereich und mit einem Vortragsslot vertreten, wie auch bei der Biotech X. Die Prospect X findet am 10. Oktober statt. Mit unserem internationalen Team sind wir auf der GTEX Global, auch im Oktober am 14. bis 18. In Dubai, auch mit einem Stand vertreten und mit etlichen Vorträgen, sowie auf der Supercomputing im November mit Stand finden Sie auch hier auf meinem Chart. Dies schicke ich Ihnen einfach mit im Anschluss mit der Präsentation. Melden Sie sich gern an, wo möglich. Und ja, ansonsten schaue ich jetzt nochmal auf meinen Fragenpool. Derzeit sind noch keine Fragen angekommen. Esther, I haven't get some questions at the moment, so I think there will be some afterwards. So
Okay,
I will
no
hand
problem.
over to you if there are some questions. Genau.
Okay, thank you so much.
You're welcome. So, dann sage ich einfach vielen lieben Dank. Thank you so much, Esther. Und vielen, vielen Dank an alle Teilnehmer für dieses Webinar. Ich wünsche Ihnen ein schönes Wochenende und sage lieben Dank vorab. Christina Sehe von der Boston. Ich hoffe, wir sehen uns im nächsten Webinar wieder. Ich würde mich sehr freuen. Wünsche Ihnen vorab ein schönes Wochenende. Vielen, vielen lieben Dank.